So, welcome to this talk called Visualizing Qualitative Data, an Introduction to Leximancer and Other Tools. My name is Dr. Daniel Angus, and I'm a researcher at the University of Queensland in the School of Communication and Arts. My background's in computer science, and I have a specialization with the development and application of computational methods for social science data, with a particular interest in visualization and text analytics. So today I'm going to take you through some examples and a little bit of a tutorial on the use of some of these computational tools through a variety of textual data sets to give you a bit of an idea about how you can, as a researcher, apply these tools to a variety of text data sets to help you understand and analyze the text and the content within those data sets. So I like to begin this with a quote, and this is from one of the the world's leading information visualization scholars, John Tukey. With this quote, the greatest value of a picture is when it forces us to notice what we never expected to see. It evokes a sense that visualization, and one of visualization's most, powerful and compelling reasons to be, is that it can help us as analysts understand and see patterns and other kinds of phenomena within our data that we may have overlooked without the use of such pictures and visualizations. The idea of opening up new lines of research and new understandings within our data becoming possible through the use of useful visualization. And this has certainly been my experience, is that visualization really can help us deal with data at a variety of scales. So we're not just talking about big data here, which is incredibly on trend at the moment, and it seems like it's popping up everywhere. This also applies to smaller data sets, single documents even. The point that we can actually distill and understand and see lots of very, very interesting things within even very small data sets. So within information visualization, there's a very, very good blog called Flowing Data that posts a lot of really good examples of visualizations used across a number of domains. And within this particular post, they were talking about common misconceptions of visualization. The first misconception that they were talking about is that visualization is somehow just about making things flashy. It's about making data look good, and that's pretty much its sole purpose. We can gain as much insight without the use of visualization. It's just about making things look good and about persuasive communication. Well, that's not necessarily true. Visualization, as I said in the previous quote, can help us understand and see patterns that we couldn't necessarily see just through reads of our text data or looking at tables of numeric data, for example. And we'll get to more of this as we go through the talk. The second misconception is the software does everything. Certainly not, and the experience that we've had in dealing with information visualization and text analytics is that you as a researcher need to still be involved within the actual analysis and interpretation. Visualization doesn't do everything, and the software doesn't do everything for you. Some of the best visualizations and the best research that uses visualization still has quite a significant human effort involved in actually making judgments of the data and in also modifying the visual elements to make them do more work. And so certainly this is not about taking the human out of the loop. The third misconception is that the more information that you can overload into a single graphic, the better it might be. And that's also not true. Some of the best visualizations can actually be quite simple. And many people make the mistake that they try and overload a visualization with as many elements as possible, where in actual fact, simplification can sometimes lead to better understanding. And certainly examples I'll show you today try and exemplify that simple approach to information visualization, but do those particular individual analytic jobs very, very well. So the key message here is about targeting visualizations and choosing visualizations that do a particular individual job quite well. The fourth point is about visualization bias, and a lot of people say that visualization can be too biased to be useful, that it somehow skews results or can be used, once again, this idea of visualization for persuasion, that it can actually lead to false results and false conclusions and associations. The counter to this is that, well, of course, any form of communication, be it text or be it visual, can include bias and promote bias. And so it's not necessarily the visualization that is the problem here, it's the way that we construct our communication, be that visual or text. The fifth point and misconception to make is that visualization has to be exact. Some people think that, and this is particularly true in scientific visualization, that there is a precision, that quantities need to be represented. Otherwise, it kind of feeds into that fourth point about bias and misrepresentation. Within information visualization, there are some forms that should be exact and precise, such as schematics and maps. But even within maps, it is possible to modify and resize elements of that to achieve different kinds of goals. And so this idea of precision being ultimately important, there are many, many caveats that come attached to that. And it depends on the way in which you want to use the visualization as to whether you need it to be exactly like exact relationships between the data you're representing and what you're seeing on the screen. But the general principle about utmost across all of these is that as an analyst and as someone that's constructing visualizations, you should focus on the story and the data. The point being that visualization is about getting you closer to your data to find out what is interesting within that. What are the stories that are buried within there that the visualization can help evoke and also help you communicate, either through that same visualization or maybe through another, or in fact, even just using a visualization as an analytic tool, taking a result and then expressing it in words. So today I'm going to talk mostly about text. And one of the interesting things I find about text is just how much of it there is. Text seems to be everywhere. And I talk about this as data in the wild. The idea that we've actually got a lot of unstructured and semi-structured data out there in various forms. Databases of emails, social media data, large document feeds, Hansard. Everywhere you go, you seem to find lots and lots and lots of textual data. But a lot of this is just sitting in unstructured corpora. So you've got large collections of, say, council meetings minutes, or what have you. All this text data sitting around in various different locations and somewhat unstructured. So within one particular data set, you might have it formatted in a particular structured table format. In another, it might just be plain text files. A lot of this textual data seems to not actually have rules around how you represent particular elements within it, and certainly not like we have with other numeric style data sets, such as statistical data from, say, a government organization that collects demographic data, where it might include all kinds of linked data and be very, very structured in its nature. But the point about the textual data is that it's actually expanding, and the rate at which we're creating text data is expanding and outpacing our capacity to be able to make sense of it. We're creating so much text data right now that we can't actually read all of it to be able to reason and make sense of all of this information. And the traditional analysis methods that we might have used in the past are largely numeric. They're built to handle very small data sets and are often limited by our own human processing constraints. And so, kind of to sum that up, it's that these traditional analysis technologies and techniques are not really up to the task of being able to deal with lots and lots of unstructured or semi-structured text data. And so that's really where visual text analytics comes in. So visual text analytics is a set and a family of computer-driven analysis technologies, and they're built to handle large volumes of data. So this could be anything from a corporate database, and that could include everything from emails, minutes of meetings, formal policy documents, communications, any form of textual data that might sit within a whole corporate database. You could take things such as internet forums, and there are some internet forums that generate massive amount of data on a daily basis. Microblog feeds, so think about any kind of social media platform and how much textual data is generated on any of those in a given day. And then you could also look at, say, media, so newspaper articles or clippings on the scale of years. So all of the actual media data that's being generated by these professional news organizations. And visual text analytics can take any of these kinds of forms of textual data and generate visual representations and also quantitative metrics that can then be used to form the basis of an analysis and some kind of research by a trained expert who is, you find people. So the idea of being that we train ourselves as researchers to use these techniques to better be able to find out the relationships. And it's not about the computational tools taking our job away. You've got to think of this as a better shovel, right? That, at the moment, you've only got a tiny little spade to kind of dig into the data and try and figure out what's going on within there. And what these tools are doing is giving you a very, very large backhoe loader that you can then go through and actually handle a larger volume of data and still generate, very, very valid and certainly, findings that are generated from the data itself, but you haven't been removed from the loop. So there's two elements that I'm going to talk through today that really kind of define the various techniques that are out there. And these elements are time and space. And so when we talk about space, it's the idea of, what is X? What is this thing that we're talking about? And then we can talk about other ideas in space about how X relates to Y. And so this might be something like, if we're talking about news media, how does a particular issue relate to a particular person? And there might be some kind of thematic or conceptual relationship that binds those things together. But then if we think about time, where it might be interested in how these spatial concepts change over time. So how does their relationship change? How does their prominence within a media or some other kind of data set change over time? And I'm going to show you two techniques that can really harness and I guess reveal these time and space concepts. So the first one we're going to talk about today is Leximancer. Now, Leximancer is a software technology that was developed by a colleague of mine, Dr. Andrew Smith, who works for the Institute of Social Sciences Research at the University of Queensland. Leximancer it's a company in its own right, and it's a commercial software product. I don't have a stake in the company, but I do use the tool pretty much daily, and I use it for a number of different kinds of tasks, and I'm going to go through some of the ways in which we can use it right now. So what is Leximancer? As I said, Leximancer is a software tool and it's designed for analyzing natural language text data. So this is anything from research texts through to media, news media, through to social media data, pretty much anything that is represented in a text-based form, even survey data can be used. And it uses a Bayes-inspired statistical algorithm. So these Bayesian-inspired stats, what they try and do is build associations between word groups and word families. So it can generate initial analysis in a matter of seconds or minutes. You can put in thousands upon thousands of pages of data and actually receive an analysis in a matter of minutes. And it automatically analyzes the text collection. By automatically analyze, I don't mean it interprets. What it does by analyzing, it feeds the data into the algorithms, it generates a set of prototype concepts, and then it can reveal those concepts to the trained analyst to actually make decisions and represent those. So it does all of the automated approach to figuring out what's being said and what are the prominent concepts and themes within a data set, but then it can direct and allow a user to add, remove, merge, or manipulate those concepts in any manner that they might want to do. And that's really kind of harnessing the power of the analyst within this and saying, well, actually, you have the power because you understand the domain, you understand the context, and you can actually direct this process to some degree if you want to. And so what it's trying to do is extract semantic meaning information within the textual data set and also relational information, how concepts relate to one another. And the outputs that it generates include everything from a concept map, which is a visualization of the concepts and how they relate over the entire corpus. It could be used to create things such as network clouds, how things actually connect to each other, quantitative data, and also thesaurus and other kinds of textual information about how prominent particular concepts are and how they're actually built within the system. So this is kind of a visual representation then of all the ways in which the software can really be used. You can generate Leximancer analyses from PDF documents, Word files, Excel documents where you might have structured tables of data. That's perhaps one of the more useful ways in which you can input data into Leximancer, in my opinion, because you can actually relate quantities together. So for example, if you had news data, I can create columns for particular news organizations and name them. I can also create columns for the edition and other kinds of categorical information. And the analysis I generate can then be broken down according to those various categories. You can put in web pages, and you can also put in just plain text files. So all these things that can be fed into the system, and it's just a drag and drop interface, very, very easy to use for anyone, even a fairly novice computer user. And then at the bottom there, we see all of the various outputs that can be generated. So on the far left, in the bottom left corner, we see a Leximancer map, the concept map, and we also have the thesaurus next to that, which shows what are the concepts and what are they actually composed of. Then we have the Insight dashboard results, which are the other two graphics in the table there. And all these various things allow us to see prominence and relationships between the conceptual content of the text that we fed into the system. So how does Leximancer actually do this, this concept extraction? So within a Leximancer analysis, a concept, I guess the guiding principle behind this is that the terms around a word, so the words around a word, indicate its meaning. So we gain meaning to a word by what it kind of the company it shares. And so these word associations are used to discover concepts, and this can be fairly language independent. It works across a large family of languages. Ones that doesn't work on that well are ones that do large compounding, that create very, very big words where all the modifiers are actually part of the word itself. And so within that, what Leximancer is trying to do is get a sense of the word association by the individual words themselves and how they relate. So a Leximancer concept is essentially a group of related words that travel together in the text. And these evidence words can include synonyms and adjectives, and the concepts themselves begin as a seed word for coding and evolve to this kind of large thesaurus. There's many papers written of Leximancer that goes into this aspect a little bit more deep than what I can do right here, and I'd encourage you to read that and also the Leximancer manual to get a sense of how it actually builds its concepts. But let's just go through a practical example. So this co-occurrence data that Leximancer uses to build a concept, we look at the example here where I've just taken a piece of text from Wikipedia on aircraft. It's saying that the necessities for aircraft are airflow over the wings for lift. The bolded words here are aircraft, airflow, wings, and lift. And those repeated term collocations imply that there's a relationship between these terms, that if I see a word wings, it's actually related to the other words of aircraft, air, flow, and lift. And when you see any of these words, it can actually create evidence, weak evidence to begin with, that the other words or this kind of sense of a concept is present. And we usually measure this within a few sentences. So the idea that we look across a text and we actually try and find out what words seem to be traveling together. And so what a concept actually becomes then is just one of those words that's being promoted to become the name of the concept. But the concept's actually a group of words that kind of bind together. So in this case, we've got 5 words: bark, cat, breed, pet, and dog, that are evidence terms that evoke the concept dog. And dog's chosen as the name of the concept because it's the one that has the highest weighting within this collection of words. So it's present most frequently within a variety of sentences that also mention the words bark, cat, breed, and pet. And so we bind these together and create a concept. So if I'm reading a text later, or sorry, Leximancer is reading a text later, and it's trying to find out whether a particular sentence contains the concept dog, it might only see the words bark, cat, and breed. But that might be enough evidence to suggest, well, actually, the concept dog is present, even though the term dog isn't mentioned within that sentence. So the idea of accumulating evidence to predict the presence of a concept. Importantly, concepts can actually be made up of the same words. So words can be shared across concepts. So in this example here, words such as bark and cat are evidence for the concept dog, but they can also be evidence, and to differing amounts and weightings, for the concept tree. And so words can actually be part of multiple bags. And so within some examples, we might find that both the concept dog and the concept tree might be invoked when we talk about bark and cat. Or it might be that if only bark is mentioned, well, actually tree becomes a concept that has high prominence, and there might not be enough evidence for dog. And so this is how we can, the system can start to do and figure out synonyms and word usage in that context. And so carbon tax within this example here is a very present concept, and is mentioned with high prominence in the Queensland Times because it's closer to that red tag of Queensland Times. Also close to the Queensland Times are concepts such as Greens, politicians, Labor, Gillard, lie. And so what this evokes is a sense that the letters to the editor in the Queensland Times are focusing on people and politicians. The idea that the letters themselves are blaming the politicians or somehow invoking them within their outrage at the introduction of a carbon tax. Whereas in the Northern Star, we see words such as better, concepts such as better. We're looking at things such as industry, water, renewable, energy, clean, emissions. All these words that are more focused on the actual broader concept of climate change and mitigation and ways in which climate change could be potentially abated. And so within that, it's no surprise that you find an audience within the Northern Star that are largely supportive of action against to mitigate climate change, whereas in the Queensland Times, we get quite a lot of people who think it's some kind of conspiracy or are highly unsupportive of the government's measures at the time to actually abate the production of carbon. So yeah, this is what it allows us to do, is visually map out the concepts, these theme groupings, which are these large colored circles, and get a sense of how these concepts lay out and how they relate to each other. So within each one of these concepts, the proximity implies a relationship, and their overall kind of layout on the map gives us a sense of the kind of conceptual landscape of this particular corpus of data, these letters to the editor into Australian regions. So slightly differently then, if we want to now look at analyzing temporal dynamics, so not so much about just the layout of concepts and how they kind of spatially organize, but how these things actually might change over time. So if we're looking at, say, an issue and how the representation of the issue in media might change, if we're looking at a field of science, that we're interested in the journals and how the journal articles have changed in terms of the kinds of issues that are being dealt with within those journals over time. The tool that's probably better to be used here is a tool called Discursis. So Discursis was developed by myself and also colleagues, Professor Janet Wiles and also Dr. Andrew Smith, who was the inventor of Leximancer. And so Discursis uses Leximancer's concept engine, but it uses it in a different way. So rather than trying to map spatially and create a spatial layout for how things over the entire corpus are related, within Discursus, we're interested in more kind of temporally based data. So this could be things such as news feeds, microblogs, social media, conversation transcripts and discourse data, or other structured text documents. We're interested in the actual structure, so that we're interested in the flow of a text to see if, say, paragraphs link across the document, whether the conclusion links to the introduction. So actually quite good for a thesis, say, to see that the thesis actually is structured in a particular way and mentions particular concepts at the right time. Now, the unit of time that we can determine, we can do this in any way we like. And so it's often determined by the nature of the text, though. So, for example, we could input the unit of time, the basic utterance, as a sentence, paragraph, or page of a document. It could be a whole article, say a whole scientific article. We could have a tweet or a status update, a blog post as an utterance, or, for example, a single turn or a group of turns in a conversation. So what we do then is we take the entire text we're interested in analyzing in a temporal way, and we actually code all the utterances with these concepts. So, for example, this utterance here, which is taken from a piece of discourse where someone's saying, "I took Seymour for a walk in the park and let him off the leash for a bit of a run." Now, it's pretty easy to see this because we actually have a sense of language, and we can understand statements such as this using our own knowledge and background experience. It's pretty easy for us to recognize that Seymour in this instance is probably some kind of an animal, and he's probably a dog, because this person's talking about taking Seymour for a walk in the park, which at that point, that could be a child, it could be some other kind of family member. But the moment it says, "and let him off the leash for a bit of a run," you'd probably hope it's an animal. And that's exactly what has been picked up from the concept model, that dog is implied with some sense high weighting, and also walk as a concept has a high weighting. Home as a concept isn't really present there, and there could be many other concepts that might not be present, and I just included one in that example of the concept home. But the important two here are dog and walk. So in this example, the text doesn't actually mention the word dog, but the concept dog, if we think back to that example I gave before, is implied through evidence terms such as leash, or park, or walk, or even Seymour, because this concept model will have been built from that text itself in a conversation, which might have linked Seymour to other aspects of what it is to be a dog. And walk as a concept is implied because the term walk is there, which would be quite strong evidence, I would imagine, for the concept walk. And some of the other words there might also be evidence for that as well. So what we do with this when we've coded it completely, now I understand this is quite a leap at this stage, so just bear with me. Just let's look at the graphic on the left-hand side. So this is what Discursus does. It takes every single utterance and it places it down a diagonal. So if we start off in the top left, this little red square at the top left-hand corner, near where it says universe of this particular plot. And then you draw your eye down the diagonal and it alternates red, blue, red, blue, red, blue, red, blue, all the way down, and there's varying size squares. Those squares are the turns in a conversation, and these are actually conversations, these are broadcast conversations on Andrew Denton's Enough Rope program. And so Andrew Denton's sitting down in this case on the left with Professor Brian Cox, who's a physicist and a popular scientist, and he's talking about, all the mysteries of the universe within this particular interview. And so they're taking turns between each other to speak. And so this is what the color represents. Red is for Andrew Denton, blue is for Professor Brian Cox. And so what we see is the size of the square is proportional to the size of the turn, the number of words within the turn. And it can also use real timing data if you do have that available. And so that's the first element of the visualization to take note of, is who's actually speaking when and for how long. And we can see that, thankfully, Professor Brian Cox is doing the majority of the talking, which is pretty good if you're running an interview program that your guest is actually doing the majority of the talking. But then what we've done with this what Discursus has done with this particular transcript is it's built the concept model and it's tagged all of the utterances, all these turns, with the concepts that might be present there. And when it does this coding, it then looks for pairs of turns that share conceptual content. And there's some good examples of this. So, for example, what we might see in this large kind of highlighted triangle here is we see a lot of these off diagonal shadings. So we see a lot of blue squares, and we see some squares that are shaded red and blue, kind of in a triangle, like a half and half shading. And what these do is they link the vertical to the horizontal elements. So if you look at any square below the diagonal, and then you actually just draw in your eye line, just go directly vertical and directly horizontal from that square, where it intersects the diagonal are the turns that share some conceptual content. And so what this is actually allowing us to see is at what points in the conversation these two individuals shared and reused each other's concepts. And so if we see a blue square, that actually means that Professor Brian Cox has repeated himself. And so he's repeated something or developed a particular narrative within that conversation. And that's what this large triangle is actually isolating. It's isolating a point in the conversation for where a lot of Professor Brian Cox's turns were repeating the same sets of concepts. Where there's white space, there's very little, or there's no conceptual overlap between those adjacent turns. And so directly below this large black triangle, we actually see a bunch of white space. What that would suggest is that this later part of the conversation, which is talking about themes such as sea, theories, energy, is not actually repeating content from this earlier part, which is talking about universe and spin. And so there's a disconnect in the conversation where they've kind of, or Professor Brian Cox or Andrew Denton has kind of changed the topic a little bit. And we can kind of see this. It can almost look like a staircase that's kind of on its side as it goes down. If you're getting little blocks of kind of engagement where the people are talking about or repeating the same concepts, and then white space when there's no link between those particular points within the conversation. And so from this particular study, what we found was that we can see within conversations with experts, there's particular patterns that emerge from the visualization for those kinds of conversations. And they're very different to the ones if we look at the right now. And this is a conversation between Andrew Denton and Renee Rivkin. Qualitatively, very, very different visual patterns. And what we see on the right is that there's a lot of red squares. And what that indicates is that Andrew Denton's repeating a lot of his conceptual content. And if we look at this example that's actually written out, Denton's asking a question repeatedly about Renee Rivkin when he was taken down to a cell. Renee Rivkin was convicted of insider trading, and Denton's trying to get to the events that happened and transpired at the point which the conviction came down and he was escorted down to a cell. And what we see here is that Renee Rivkin is not engaging and actually engaging with Denton's questions because we don't actually see any red to blue connectivity. So there's no squares that indicate an overlap between those individuals, and so therefore those elements are white, and we can suggest then that there is actually very, very little conceptual repetition between these individuals. So that's one way that we can analyze temporally the kinds of concepts and what's being said and how individuals can relate to each other in a discourse. There's other ways in which we can use this kind of temporal data though, and I'm just going to take you through and finish off now with a case study that brings both Leximancer and Discursis together to analyze a very, very important case, which was the representation of coal seam gas within the Australian news media. And so what we did was we content analyzed 14,148 Australian news articles that we collected between 1996 and 2013. We used a variety of kind of clipping services to collect and gather this data. And so it was every article we could find that essentially mentioned coal seam gas or variations on that, such as unconventional gas or that. And we mapped this kind of news content over time. So we're interested in how the coverage of this issue had matured or changed over time. We're also interested in identifying actors within it. So we used other tools, natural language processing tools, to identify key individuals, politicians, industry people within those news articles as well. And we're interested in also mapping the prominence of them within this particular debate that was playing out within the media. So our sources from Factiva, we got about almost 1,600 regional and rural publications. State-based publications accounted for another 1,600. There was a few online sources such as news.com.au and Crikey. The Australian counted for quite a large number, and as did the Australian Financial Review, ABC News, and AAP. And this is one of the Leximancer maps of this data set. And so if we look at this particular Leximancer map, we notice there's a few kind of thematic groupings that are emerging. If we look at the top right in this kind of greenish bubble here where we see shares, bid, market, trade, price, these concepts in this theme is really about the trades and kind of the stock market aspect of this industry. And it's really about takeovers and the actual companies themselves that are looking to extract and sell or even prospect around the coal seam gas industry and all that kind of business movement that was happening there at the time. We look next to that theme, and there's a related theme called project. And this is actually talking about projects themselves. So at Fisherman's Landing, at Gladstone, plants, barrels, this idea of the actual coal seam gas projects and how that actually relates quite due to that proximity to these shares and the bids and the assets. So it's the idea that it's already giving us a sense of linking between the project focus of the media on projects that are happening and how they are all on the business pages around and related to things such as shares and assets. And then as we move across more towards the bottom left-hand corner of the map, we actually see the story of the farmers, right? The land rights issues, BTEX, which is a chemical, and that being related to water. So this kind of threat that many saw around water security and the way that that was being played out in the media as well. And then how that relates to things such as the Greens and mining and environmental and government regulations and such. And so we kind of see all the different sides of this story. There's this business side, but there's also this kind of community concern side to the story. And we also go, there's aspects of jobs as well, and protests and police. We see this in this purple node at the top left-hand corner. We're talking about police and property and protesters. This is all about the Lock the Gate movement and how people were actually meeting and protesting and actually going to sites, local sites, to protest and to kind of lock the gate and stop this this mining from happening. And so when we refined this down, we actually had a lot of goes at trying to figure out what are the best themes that can represent this story. We actually drove it down to about 4 themes. And so this is one of the great things with this tool is that you don't just get that one map and that's the authoritative map. You can kind of manipulate it until you get to the point that you think that the map actually really reflects what you understand of that issue. And this was really working with my collaborator at the time, Dr. Elizabeth Mitchell. We kind of got to this point where we thought, yeah, these are the 4 major elements to this kind of story. One around energy, another around shares and sales, another around business projects and economy, and the 4th one around industry and its relationship to the environment and community. And so these were the real kind of 4 emergent themes. So with these in hand, what we could then do is actually do the temporal analysis and see how the prominence of these themes has changed in the media over time. And that's what this temporal analysis shows. So what it shows is that early on, within, from right back to 1996, the majority of the news interest and the issue prominence was around this like business projects and economy, this grey theme here. There was some talk also around energy and shares and sales. And very minimal coverage of environment and community concern as a theme and issue. And it wasn't really up until about 2010 that this kind of got a bit of it got perturbed. And it was around this time in 2010, this is the point at which communities such as Lock the Gate really started to emerge. And they emerged off the back of a movie actually called Gaslands, which showed over in the United States. This was some of the early stuff on like setting water taps perhaps on fire, and communities that had water that had been polluted by this particular industry over there, particularly in Pennsylvania and other states, in upstate New York and others. And so what this did was it really changed the media landscape and created new news values for this story, ones around environment and community. And what we saw then is that the mixture of the media really changed. Also, at this point, you can't really see it on these slides, but that white line is the number of articles being published. And so that actually relates to this right-hand bar here. And so that the peak in this issue's prominence of coal seam gas in general really peaked in about 2011, 2012. And it's that point that this environment and community aspect of the story was so highly prominent. And so this really allows us then, this tool, to unpack this whole kind of massive issue, lay it out temporally to see how it's actually changed over time. So you can imagine doing a similar analysis for any kind of textual data set that has some kind of temporal element or is organized in time in some way. And so, yeah, as I said, we also looked at the prominence of individuals. So there's another tool called the Stanford Natural Language Processing Toolkit, and that allows us to actually pull out names and named entities. And so we're looking at this as well and seeing what are the prominence of particular individuals. Now, we call them stakeholders and stake seekers, people who are actually involved in the industry in some way, and those who are looking to actually attach themselves to the issue in some way, mostly politicians who are getting in there and trying to actually use this as an issue to boost their particular credentials or use it in some way to gain a particular following or popularity. And so we kind of broke this down across the various actors and looked also how do those people and their mentions within the media change over time as well. And so this is another temporal map showing the prominence of these particular individuals. So early on, and this really kind of bolsters the previous analysis because it shows that absolutely industry names and figures are the ones that are mentioned early on within the piece. And this is actually just a truncated timeline. This is not showing all the way back to 96, only to 2008, just to show this change around the 2010 mark when we saw that big spike and the upswing in the environment and kind of community concern. And so we see that point is when we see less industry voices and we're seeing more politicians and issue advocates. So issue advocates are people such as the Basin Sustainability Alliance and also Lock the Gate. And these figures are starting to emerge within the actual media discourse at that point. And so what we kind of found from this, just to conclude and give you, I guess, a result of this analysis, was that within these elite voices, they talk about this sometimes in terms of elite retreat, the idea that elites, be they scientists, industry, politicians, are they, like when there's elite retreat, it's that they're actually removing themselves from the conversation, from the discourse, and not giving comment or not being heard. Within this particular case, we saw it more as a failure to compete. The idea that the number of articles was increasing so steeply that there's only so many articles that you can provide comment for. And so the share of voice was actually decreasing when we actually take it as a percentage of the number of articles. The number of mentions was fairly stable. So these people that had been giving comment early were giving the same amount of comment later, but the number of articles was going up. And so their actual percentage share of voice over the entirety of the news coverage was actually decreasing because they weren't scaling their voice proportionate to the number of articles that were being written on the issue. So I'm just going to kind of leave it there, and at this point, I'd welcome questions. And so you can find more information on both the websites, discursus.com and leximancer.com. But just to kind of wrap up where we kind of got to here is that just what I've tried to show here is just a few examples where these particular visually driven qualitative techniques can be used to analyze textual data sets at various scales. And so I showed you that example from Denton, where we saw it on the scale of a single discourse, a single talk between two people that only went for about half an hour. And then we saw it actually kind of on the large with an issue where we had 14,000 news articles and how we can distill that down also to a single image that can give us some very, very useful information about the nature of that particular discourse. And so really this is something that can work at various scales, and both of these tools offer you something different. Leximancer, on the one hand, the ability to see what's being said within a document and distill that down to a single image that gives you a thematic overview of what's kind of being said. And then Discursus is something that can actually provide you with more of an idea of the ebb and flow of those concepts over time to determine prominence, be it rising or falling, and how a debate or some other kind of discourse is evolving over time. And so really it's about finding the right tool for the analysis that you want to perform. So what I really want to encourage you to do is think about what are the kinds of analyses and stories that you want to tell or want to get a better understanding of, and think about the kind of data you have, and then what can you do within tools such as this to get a better sense and kind of help your analysis. And of course, I welcome questions at this point.